For most people, robots are a concept that feels both familiar and unfamiliar. Familiar because we've seen imaginative robots in movies and anime. Unfamiliar because we rarely see fully developed robots in our daily lives. At best, you might encounter noisy vacuum cleaners or restaurant delivery robots, but the technology behind this is quite basic. Most robots currently used in homes or factories operate based on preset programming. Or to say robots like vacuum cleaners or robotic arms lack true intelligence, cannot learn or reason on their own and are limited to specific tasks. However, humans expect robots to adapt to various environments and handle diverse tasks, not just to perform a single task. Imagine robots that can do housework and also work in factories or hospitals. In other words, robots that can handle both household chores and professional tasks. This is where the concept of embodied intelligence comes in. Simply put, embodied intelligence allows robots to interact with the physical world using their bodies, enabling them to learn independently and adapt to complex environments. This requires an effective combination of AI algorithms and robot hardware. While this vision of embodied intelligence is promising, achieving it remains a long journey. Artificial intelligence has made significant advances, such as winning chess matches or helping develop new medicines. But did you know that simple tasks for humans like folding clothes or wiping a table, tasks that involve real-time interaction with the physical world, are extremely difficult for AI? These challenges involve large amounts of training data, real-time sensory equipment, and reasoning capabilities. Bridging the gap between AI software and robotic hardware also presents hurdles. Despite these challenges, some research teams are steadily working on embodied intelligence. One such promising company is Physical Intelligence, a robotics startup founded in 2024 in San Francisco. Physical Intelligence aims to create a universal foundation model that can control any robot to perform any task. Essentially, the company focuses on developing fundamental robotics software. In October 2024, the company launched its first product, Pi Zero, which some in the robotics industry see as a major milestone in the development of embodied intelligence. Shortly after the release of Pi Zero, the company secured $400 million in funding in early November, valuing the company at $2.4 billion. Notable investors include Jeff Bezos, OpenAI, Thrive Capital, and Lux Capital. Earlier in March 2024, Physical Intelligence raised $70 million in seed funding with a valuation of $400 million. Within a few months, the company's valuation grew sixfold. This alone makes us curious about what's special about Pi Zero and its technological highlights. Pi Zero was trained using data from two sources. One is open source data from the internet, which are mainly visual and language pre-trained datasets. The other is diverse data from 8 types of robots. These datasets included tasks such as placing food in containers, folding clothes, and washing dishes. The goal was to teach Pi Zero how different physical forms interact with the world and how objects behave in various scenarios. This data helped Pi Zero learn the basics of physical interactions and flexibility, such as handling objects of different shapes and materials. Unlike task-specific robots, Pi Zero focuses on general control and operation capabilities that apply across different types of robots and tasks. While still in its early stages, Pi Zero represents a mix of training across various physical embodiments. Pi Zero inherits semantic understanding and visual comprehension from pre-trained vision language models. These models, trained on large-scale internet datasets of text and images, provide semantic knowledge, like language meanings and image features. Popular AI models like GPT-4 and Gemini also use this approach. However, traditional vision language models output discrete language responses, while robots require continuous action commands, like moving a robotic arm. To address this, physical intelligence developed a breakthrough using flow matching, a diffusion model-based technique that converts discrete language models into ones capable of producing continuous action commands. By combining vision language training with high-quality robotic data, Pi Zero achieves both semantic understanding and action flexibility, enabling it to handle complex tasks. Complex tasks often require additional fine-tuning. For instance, to teach a robot how to neatly fold a pile of clothes, a task much harder for robots than it is for humans. Extra training is essential. Pre-training helps robots understand general physical properties and basic motion rules, but fine-tuning focuses on specific task details. For folding clothes, the robot must sense and adjust to unpredictable variables like tangled fabrics, different materials, and random placements. This requires precise perception, action accuracy, and real-time planning. So far, no other robotics companies except Physical Intelligence has achieved this level of dexterity in such complex scenarios. Physical Intelligence Pi Zero is still in its infancy, and developing a universal robotics model has a long way to go. Key research areas include long-term reasoning and planning, self-improvement, robustness, and safety. However, the company's progress offers a glimpse into how embodied intelligence could become a reality, one step at a time. Science fiction is gradually becoming science fact, and physical intelligence is paving the way. Okay, that's it for today. Thanks for your watching. See you next time.